So I'll continue on the topic about information models and the importance of them. We've already heard today quite much about it, and Christopher was talking about the machinery job management, which is the latest advancement on that. As Stefan mentioned, we have already a lot of models. So I want to emphasize on their importance on the OT-IT integration still a bit more, and maybe a little bit how we approach it. First of all, I'm the deputy CEO of Prosys OPC. I've been working at Prosys over 25 years. Purdy joined only 97. I already joined 96 when we were establishing the company. But we have a management team of three major managers, and fourth shareholder nowadays, one of our main engineers as well. So with that group, basically we've been running the company for over 25 years. And we started working on machine communication to just expose some data from devices, but OPC came around 1995, the same year that the Prosys was established, and therefore it became very useful for us, and therefore we started using OPC Classic to help our customers, many of them in Finland and around the world, and started creating components also for helping the development of OPC Classic communication, and then later on also the OPC UA, of course. And today we are the world leader in multi-platform OPC UA software, based on the fact that nowadays we do most of our development on Java, and Java provides multi-platform development from kind of single source, or for sure. We are located in Espoo, Finland. We are around 20 engineers there, and we have been partnering with OPC Foundation with this Java communication starting 2006, and then taken over the development to make it more usable for the users. So our main products are the SDK products for Java and Delphi. That was our first environment from the 1990s, but it's still used very much, although many of you maybe don't believe it anymore. But we still have customers requiring it. And then we have the applications built on top of that, the server level applications like the simulation server, Modbus server, Historian. And then the client applications, the browser and monitor that was exposed in Advenica presentation as well. And the latest achievement is the Forge, which is sitting somewhere in between. And it's kind of the Unified Automation UA Gateway is doing a bit similar role there, but we are trying to emphasize more on the information modeling parts and perhaps client-server conversions and that kind of things. We are also a member of the Open Industry 4.0 Alliance, which is nowadays also like a member of this MQTT working group that Matthias was talking about. So together with them, we're looking for use cases, how the MQTT can be used as this kind of a maybe standardized message bus to exchange certain data sets. And they're more or less looking at the use cases for the data, whereas OPC Foundation is providing the technology and models. So the outline of the presentation is the first vision, then the information models, and in practice, how could this work? So the vision is that there is different kind of data coming from different kind of machines and production lines, and through the edge, you need to take it to MES level or higher. And there can be more and more machines, robots, different kind of equipment that is added on the production process. And all that needs to be first connected, like configured to the communication line. And after that, you can start monitoring data from those machines. And of course, this should all be more or less automatic to make it plug and produce. And now with the standardized information models, we could achieve something like standardized delivery of production orders to the machines, and as a result, basically also like get standardized reporting back to the MES level. And these are some kind of use cases that many people in the industry are looking for, but this doesn't really exist today. But this is the vision that they would like to do. Also, you could do the incident management on the side by browsing the information on the edge level and just seeing what's the status of the communication and those kind of things. So why are the standard information models important to establish this vision? As an example, Pyry gave a presentation at the Industry 4.0 TV in YouTube. Industry 4.0 TV is making a lot of podcasts or programs in the YouTube about different topics in industry, a lot about OPC UA as well. I talked about information models there as well. And in this demo, we showed how the Prosys OPC UA Forge can help in establishing this vision. There was an idea of it's simulating some wind turbines, harmonizes the data, assuming that the turbines are not harmonized from the start. And then with a harmonized data model, you can build autonomous dashboards so that you can basically create these screens, assuming that all the data is in a certain format. And when you plug in more wind turbines that provide the data in the models, like now in this case, the models that Espen was talking about for the windmills, you could build this kind of monitoring screens very, very quickly and very easily. So this is the vision. And that's the reason why these information models exist, so that you can create these kind of applications easier. Okay, you already heard about the information models, but some like basics, what are they? So OPC Foundation is defining a lot of these standard generic models, like the devices model, the machinery model. They are more or less generic models, but then there are a lot of domain-specific models, for example, for robotics, for woodworking, for machine vision, and different kind of machinery. Plastics and rubber machinery have a lot of different models already. PackML has its own OPC UA model. So these are the domain-specific models and these have been created by this vast network of organizations that Stefan mentioned in the morning, that OPC Foundation is establishing this cooperation. So the OPC Foundation is not defining these models. The experts of each domain are defining these models, but OPC UA can provide a common language to like define these models. And today there is a great number already. We have already around 82 working groups defining these models, and I think Stefan mentioned there's 151 published models already by the OPC Foundation, and then also companies and small organizations can publish their own models on top of this. So it's already very much established. And it can be like a machine description driven, or it can be use case driven approach that you can take into this model. So of course the modeling is not a simple task, and therefore it's like quite great to see all this number of models that we already have, and it's expected that they can have like clashes, or there can be several models that do almost the same things, and therefore also this kind of harmonization actions that Espen is driving at the energy field are very important. The OPC Foundation also has a harmonization working group which tries to like review all the models and check that is there some generic features that should actually be not in some domain-specific models, but taken out to some more generic models. And this is also how the machinery has started, as Christopher explained, that the job management didn't, and the other like state aspects of the machines, they didn't come from the machinery working group, they came from the other working groups that already needed those features. But it doesn't make sense that all the domains define their own job management in a different way. We need to have one common model for that. These are the challenges. And as Stefan mentioned, most of these are available, or I think now all of them should be available from the cloud library that OPC Foundation is providing. The cloud library can be this like global cloud library, but it's also possible to make an on-premise installation of the cloud library if you want to use your own models and add more customer-specific models in there. And that's the vision, how you can provide those models also to the cloud applications. As Matthias explained, the cloud or the MQTT communication is just basically providing the data. But then if you need the models in the cloud library is a resource where you can find them and use them in the cloud applications. This could be an example. This is what's defined in the devices model, the vendor nameplate. So this is already the first level of standardizing the identification of devices. So if every device defines this information in the same way, then we can already start like asset management. And this is also what the Open Industry 4.0 picked as their first kind of use case. The master asset model is based on this information definition, that if every device publishes this information, then you can already start collecting what are your assets and what's their manufacturer information, serial models, serial numbers, and so on, and keep track of your assets automatically. And with the discoverability that Matthias explained in MQTT, once you plug in new devices to the communication network and they provide this information, you can already like put them in your registry and you know which assets you are having there in the factory. Or if you replace one when a valve gets broken, for example, and you need to replace it with a new valve, you will get automatic like updates to your registry according to that in principle. And then from this on, it goes higher level, like more and more information that will be really shared. And in practice, we have this basic problem that the devices and machines, they don't today support these models so much. So how can you advance? Can we just wait for the time when the models will be available, or is there something we could do already before that if we want to make these dashboards, for example? So of course there's an option that we can have a middleware component that can understand these models and that can remodel, as we call forge, the data to be aligned with any standardized information model. For example, if we have a custom packaging machine and you want to convert it to PackML using the OPC UA PackML model, you could do it in principle like this in the forge. And then you can connect more packaging machines and convert them to PackML, or some of them could already be in the PackML format by default. But as a result, you can basically have them all in the same dashboard, and the dashboard doesn't need to know about the specific definitions in the actual machines. And this is very much the reality of today, that all the vendor specific implementations are different. So far, the vendors haven't had any need to care about what it looks like, what model they use. It's just the best they found for their own application. But now when they need to expose, or we would like them to expose this information, we would also like them to follow the standard. But it's not an easy job for them to change their programs and use the models in these machines. The machines also require like capabilities from the PLC or applications that they use to make these. So if we have a way to remodel data in between that would be very helpful. So if we look at a little bit forward, there will be new company specifications coming up all the time. New use cases will be covered, and people are really like putting more and more effort in this modeling, and that's been like great to see. I think one of the major advancements that is happening over OPC UA these days is all related to information models. Also, the FX is very much about information models. We have of course, the transport levels. The client server is pretty much established. PubSub is still developed, but basically the main advancement is happening here in the information model level. And these digital twins living in clouds, they could be created using the information models, and if you can transfer the data over MQTT, that's like even more realistic. So what we're looking for is seamless integration from business systems to cloud. And as I explained, like autonomous configuration and reconfiguration and plug and produce is the target that we would like to see happening. And that's what these specifications enable. So without going more to the details, just talking about this vision and how we want to like make it happen already today with providing some tools that can do these conversions when you cannot do it natively. We hope that we can help the industry in that ways.
Thank you.